So if you haven't already gone to joinpd.com, I'm going to go ahead and lower this code. Feel free to pipe up and ask for it if you need it, but it is OHXRW, orange highlighters, X-ray, red watermelons. Looks like 10 of you have made it, and I think there's 10 of you in here, so. Well done, first step achieved. Okay, so what is Pear Deck and why do I use it? It lets you communicate with me. So you should have a little blue dot. And you can put the little blue dot anywhere on that screen and I can see it. And I think I can let you see it. Ah, all right, I can stop explaining Pear Deck. That's how I know that. So we will go on to the next slide. Okay, this is basically a duplicate of what you just saw in case we took a break. Don't forget, you have to be enrolled for the lab. If you haven't already, last I checked, everybody was, but we'll see how people shift around their year. You cannot complete this course without the lab. As I mentioned, join the synchronous course, which you've all got an A+ on. Tell all your friends, join the synchronous course. It doesn't cost you anything, and it gains you live, earlier lecture access. I'm going to go ahead and get that wiki template page up tonight, so don't look for that today, but tomorrow it'll be available for your first assignment, and you can check out your text. So what is a GIS? You should see Pear Deck allowing you to provide verbal response. You should also know that I have anonymized Pear Deck, so you won't be held accountable for your answers. Don't use that in a wrong way, but let it make you feel more brave. Right now I see hummingbird, flamingo, and chameleon responding. So yes, GIS is a geographical information system, and it lets you digitally reference spatial data. That's a really good way to put it down in a nutshell. So what does that mean? That means visual representations of your data. That means creating maps. That means collecting content and potentially making it available to people over the internet. That means conducting data analysis, and even better than that, conducting spatial data analysis to actually extract some value from your data. You'll notice here I put a GIS. Why did I say a GIS? Because it is a system. You'll also frequently hear, what is GIS? It's kind of become its own entity. So it's developed its own persona and dropped its article. So in a nutshell, GIS is a spatial system, so it has to have some sort of geographic coordinate to put it in a real world reference frame. And it has to have data going into that. So there has to be data objects, and typically, well, at some level, there has to be an attribute tied to that object. So at the very minimum, there has to be an identifier for that object, but usually it'll have far more. So it'll have a name, it'll have a description, it'll have different categories. A lot of them you will see carrying physical information. It's pretty difficult to see on this image on your screen. But the map with the inset shows some shape length and probably a shape area. Those are usually computed from your digital data to give you an idea of your spatial arrangement and how potentially how valuable different items in your attribute table are versus another one. So here we have two different tables shown on the left. There's the blue table that shows a set of different type of part numbers, looks like probably bicycle parts. And on the right, you have information about crimes. So what is missing from the left to make it part of a GIS system? You can answer in Pear Deck. Or you can shout out in Zoom also. Right, so we're missing a location on that one. So how do you imagine you might tie bicycle parts to a spatial system? That's a great idea. So you can have warehouse storage. You know, you could have, these are the storefronts that have this item. You're going to see that a lot now. If you go to Home Depot online, you'll see mapping of where they have stores. You may see where those items are available. You may try to do a Lowe's online order and have things come from 3 different stores and not a single one of them actually ever arrives, which has been my latest experience. But GIS has become a really powerful tool in the modern age, especially for online shopping. So another way to put it from the functional end is data goes in. GIS allows you to manage and manipulate that data, and then you can choose some form of output. That may just be passing that GIS file to somebody else to use in their system. It may be serving it out over the web. It may be developing a beautiful map that you can print and hang on a wall, and then it's no longer GIS. Or some of the new systems allow storyboard creation, and we'll look at one of those in a minute. We'll skim over this real quickly. GIS science is the study of GIS. So if you think this stuff is really fun, you can go even further. Frank Whitmer, actually, I think you could call him a GIS scientist. I think I brought up his profile earlier. It was snooping, because I think he has a really interesting background. So just to give you an idea of other people that teach GIS at the university, I clicked in the wrong place. This is Frank. We've never met. He was kind enough to give me all of his slides. He has studied things like ticks distribution in Alaska. So here's another Pear Deck tool. I threw this in there because I feel like it's important to keep talking about the differences between this academic year and another academic year. Some of you may feel like it's not necessary today, but it may feel helpful another day. I've been learning new ways to communicate. As an introvert, this is kind of my dream come true. I don't have to go to an office. I can stay home and play with my GIS, but you start to miss things that you never knew you were going to miss. So one of them is actually seeing my students' faces. So please use Pear Deck and use other ways to reach out to people. So what is our motivation for GIS other than having all the tools that we described before? Frank had this in his slides, and I was thrilled to see it because this is basically being a hydrographer in a nutshell. This is our whole goal in life, is to prevent this by telling you where the rocks are. It's a really basic use of positioning with extreme consequences. So NOAA, who prints the nautical charts for Alaska, no longer prints nautical charts. They now have digital systems on the boats. So everything goes in digital, is analyzed digital, is QC digital, and is served out to the world digital. So for those of you who are coming from a survey background or have some experience in this world in another environment, I think you're doing yourself a really great service in coming into GIS and getting a handle on where tools are going in the future. Many of you already understand a million different ways to make a GPS do what you want it to do. This is the outcome and the purpose for representing that to other people. So I like this quote: almost everything that happens somewhere. There's very little that you can't, well, I shouldn't say that. There are many more things than you might imagine that you can represent in a GIS environment. What are some ways that you think you probably interact with GIS in your environment? Uh-oh, I didn't put a Pear Deck in here. Go ahead and use your real voices or the chat, and I will read out the chat.
I didn't understand the question entirely.
What are some ways that you use GIS in your daily life? Does anybody have a smartphone?
Yeah, what, like Google Maps?
Is a perfect example of something that has revolutionized our world. Anybody else? Any other?
I geocache sometimes. Does that count?
Definitely. Yeah, especially these days where it's not just a GPS served activity. It's, you can connect with geocaching all over the web, and that's how that's typically represented.
What about like using your smartphone for like tracking your run?
Yeah, for sure. I just downloaded Strava. I hate running, but I'm going to try since I can't dance anymore. Did anybody live near a Pokemon Go site? I used to watch people come and go from the church across the corner at really weird hours of the night and stand around with their smartphone trying to catch something. That's exists because of GIS. One of my favorite apps is iNaturalist. If you haven't used it, it's a crowdsourced identification for plants, birds, animals, fungi, spiders, if you want to go there. It has an incredible visual identification tool, but it is all served out over a GIS system because all of those identifications have at least the potential to be geolocated. And I actually, as an environmental scientist, use that data in my analysis of what types of species we might encounter in a project area. So that pulls together a lot of really powerful tools that have become available both because of smartphones and that type of technology, but crowdsourcing GIS. So I don't think we're going to make it through all of Frank's slides, so I won't spend a lot of time on all of them. Here's a few more examples. Another way that we use GIS information is to analyze for threats. So a really good two-dimensional example is the tropical storm headed right now, I think, for western Louisiana, Texas border. I have a friend who's right in that area, so we check in on the news. And all that mapping is represented in GIS, but it's also being modeled to a large extent in GIS. I don't know if you've ever had a chance to check out the Tsunami Warning Center in Palmer, but those people are sitting there pulling in data from seismic detectors all over the world and are actually doing real-time programming and modeling to pull that data in, refine it, and give better and better predictions of tsunami modeling. Having recently evacuated my home for a tsunami warning in Cook Inlet, I have some mixed feelings about that, but hey, better safe than sorry. My neighbor's cats didn't drown. That's one application of GIS. Actually, the University of Alaska Fairbanks had some pretty substantial funding come in to collect land survey information, aerial LiDAR information, which we'll talk about a little bit more if you haven't already studied LiDAR data collection, bathymetric survey information, which is what a hydrographer collects, and pull all of that into one data set for most of the coastal communities in Alaska and start modeling tsunamis to understand areas that are at risk and help communities plan for emergencies. And all of that was led by Elena Suleimani from UAF using GIS data acquired from a lot of different sources. You'll also see pretty extensive GIS use in land management. So national parks are a great example. If you want to seek a career in GIS, almost every federal agency has their own GIS department. So that's a good place to look for work, and also a good way to understand how your tax dollars are being implemented. These are tools that people are using to manage extremely massive assets. Let's see, so this is something Frank included from last year's GIS Day. I believe this year's GIS Day was canceled and is indefinitely postponed, but it's open to the public every year. And I wanted to show you this in particular because this is an example of a story map from Esri. It's a new tool that's becoming really popular. They typically involve maps, but not always, because Esri's just developed this really nice computer interface. So most of them have this nice scroll factor. This is just giving information about that day's presentations. But you can see, hopefully, you can see on my screen that I'm sharing. These pieces scroll by of this conference. And as I continue to scroll, different pieces come up. And this is an overview of different agencies and entities that produce or rely on GIS in Alaska. So if you have any interest in pursuing a career in GIS, these are great places to start. If you live in the municipality of Anchorage, you have a great advantage of having all kinds of GIS information about the town you live in at your fingertips. So just another example. I don't know if we'll get a chance to make our own storyboards, but it's a fun aspect of Esri's available data presentation. So what do you need to represent geographic information? What components do you think you're going to need in your data set in order to show it in a GIS?
Location or coordinates?
Great, yeah. So we're going to start out, obviously, location, topology, all of those pieces of information are important. You get into things like quantity, as Horst mentioned. No, I'm sorry, that was pterodactyl. Quantity, variables, information about structures are all things that are part of your attributes. So your attributes define and quantify your data. Your location, your coordinate system, your elevation, all of that is included in your spatial data. And then there's one more component which Goose has mentioned, is time. So your GIS information can also include a temporal variable because all of this information is subject to change over time. Horst, yes, it is working. Thank you for responding. All right. So you guys nailed it. GIS information is made up of space, time, and attributes. Attributes being kind of a big lump of categories. I think Frank might have been making a joke here. I had a former employer who had a t-shirt made up for us that said, "I'm geospatial." So yes, GIS is spatial. And also special. So here's some more information for you of different types of GIS data that we can pull together and layer, and how that information all interact with each other in really beautiful and interesting and informative ways. I unfortunately don't know what this is representing from his slide, but you can see right off the bat that it happened in New Jersey. You can see a huge concentration around Newark because most things are concentrated around Newark. So the way that our attribute data, the informative component of GIS data is typically stored is in tables. You'll also see database storage methods, but we're going to start out with the basic attribute table. So each of the features that you see on your map is going to have a item in the attribute table that presents the attribute data that goes along with it. So you may have 4,000 items in your table that each has an associated, I'm losing my words, an associated variable that goes along with it. And we'll get into the details of how those attribute tables are constructed and maintained later. There's a lot of different ways that you can manage your data and limitations you can put on your data to make sure that it's managed well. So this is a comparison of paper maps versus GIS. You can still print paper maps out of your GIS, but save the planet, don't. Keep it all digital. You can get a lot more value out of it that way. And we are running up on our last 5 minutes. So I think I'm gonna stop us there. We can get into any of these other slides that I decide are important during our lecture on Thursday. Most of our focus on Thursday is going to be making sure that everybody has access to the software and has it set up. And we'll try to do something fun and informative as well. But I want to make sure that everybody has a good solid start. So I'm going to stop sharing that and Stop, Pear Deck.